You pour the same whiskey into two different glasses. One is a familiar wide-mouthed rocks glass. The other narrows toward the top, shaped like a tulip. You lean in to smell. The aroma shifts, not because the liquid has changed, but because the air above the surface has been re-engineered by nothing more than geometry. The scent of whiskey does not live inside the liquid itself. It exists in the volatile molecules hovering above it. Compounds such as ethanol, fruity esters, and smoky phenols constantly escape the surface and disperse into the air. When you bring your nose closer, you are not inhaling the drink. You are breathing in a temporary chemical cloud, floating a few centimeters above the surface. Scotch is often served in narrow-mouthed glasses like the Glencairn for that reason. The tapered rim reduces the area where vapor escapes. A smaller opening slows diffusion into the room. Aromatic molecules linger longer right above the liquid. When you lean in, you experience a higher aroma concentration, similar to standing close to a steaming pot of soup rather than across the kitchen. Bourbon follows a different philosophy. A wide rocks glass allows ethanol, a lighter, faster evaporating molecule, to escape more easily. As ethanol dissipates, the sharp sting in the nose softens. Heavier compounds such as vanillin from charred oak or coconut-like lactones become more noticeable. The same whiskey, two different ways of controlling vapor flow. The shape of the glass directly alters a tasting experience that many people assume comes from personal preference. The story begins with simple physics. To understand why Scotch benefits from capturing aroma, while bourbon allows more alcohol to dissipate, it helps to look deeper into the structure of their flavor profiles. Once whiskey is poured, the surface touching the air becomes a continuous exchange zone. At room temperature around 20-22 degrees Celsius, ethanol evaporates faster than water because it has a higher vapor pressure. In simple terms, it wants to leave the liquid sooner. You can picture ethanol like moviegoers walking out before the credits roll. In a wide glass, the evaporation surface is larger. Molecules have more room to spread. Small air currents from movement or air conditioning carry aromas away. The concentration near the rim drops quickly. A tulip-shaped Scotch glass narrows this escape path. The tighter rim forms a bottleneck. The airspace above the liquid becomes a small accumulation chamber, where aromatic compounds gradually build up. When you gently swirl the glass, thin waves ripple across the surface, releasing more molecules into that confined space. The result is a focused stream of aroma, like opening a spice jar instead of leaving the whole kitchen door wide open. Scotch often sits around 40–46% ABV, meaning nearly half of its volume is ethanol. In 100 milliliters of whiskey, roughly 40 to 46 milliliters are pure alcohol. If ethanol overwhelms the nose, delicate notes from fermented barley can disappear. A narrower glass helps balance this by keeping complex aromas close while preventing alcohol vapors from dominating the sensory field. At this point, the glass stops being just a container. It becomes a device that adjusts aroma concentration over time. That idea explains why Scottish drinkers are so particular about glass design. Bourbon, however, takes a different path. The difference starts not with the glass but with the ingredients. Scotch is primarily distilled from malted barley. Kilning and fermentation produce light, fruity esters, subtle aldehydes, and sometimes smoky phenols from peat. Many of these compounds exist in extremely low concentrations, measured in parts per million. That means one aromatic molecule among a million others. Human noses can still detect them, but only in a concentrated environment. A narrow glass provides that environment, allowing fragile compounds to linger long enough to be noticed. When you bring the glass to your nose, you are stepping into a microspace rich in signature molecules rather than diluted by surrounding air. Bourbon, by U.S. law, is made from at least 51% corn. Corn contributes a clearer sweetness. The whiskey is then aged in new charred oak barrels. The char layer generates vanillin, caramelized wood sugars, and notes of toffee and smoky oak. These flavors are louder and more robust than Scotch's delicate fruit esters. because bourbon's aromas are naturally intense. It does not rely on a tight accumulation chamber to be perceived. Allowing ethanol to dissipate through a wider opening softens the initial burn. When served over ice in a rocks glass, melting ice increases the liquid's surface area, continuously changing evaporation dynamics minute by minute. What you are witnessing is essentially a live experiment in flavor kinetics. The same physical principles, two different design philosophies. One prioritizes subtlety. The other emphasizes richness and alcohol balance. Here is the surprising part. Many drinkers believe they choose a glass for aesthetics. In reality, they are selecting a glass-shaped aroma filter. A narrow rim does more than hold scent. It also guides the flow when you take a sip. The smaller opening encourages you to tilt your wrist further. The liquid forms a thin stream, touching the tip of the tongue before spreading outward. Flavor perception shifts along that path. A wide glass allows a larger sip. The whiskey reaches multiple areas of the tongue at once. Sweetness and oak notes spread quickly. The sensation feels stronger, more immediate. This is not a psychological illusion. It is the mechanical distribution of liquid inside the mouth. Glass designers understand this deeply. They experiment with rim angles, wall thickness, and curvature. A change of just a few millimeters, roughly the thickness of 2 sheets of paper, can alter airflow and liquid flow. When you invest in a specialized glass, you are paying for that microscopic tuning. So the next time someone says, "A glass is just a glass," try pouring the same whiskey into 2 different shapes and observe. No lecture required. Let your nose do the explaining. The glass does not change the whiskey itself. It changes how the whiskey meets you. In a world filled with tiny details that create big effects, sometimes it is worth looking closer at the objects we treat as accessories. If one glass can reveal an entire lesson in fluid mechanics and volatile chemistry, then many everyday tools around you are probably hiding similar stories. Perhaps next time we should explore why new barrels and old barrels create completely different worlds of flavor, a tale that begins with a regulation that seems, at first glance, almost boring.